Hey, hello guys, welcome to today's session. When did I start calling it session? Yeah, session. Seems like a session. Yeah. And yep, we'll do JavaScript typed arrays and today and that's what we are gonna do. Let me just bring on the chat. It's just been a very like disappointing for my chat because whenever I bring out the chat, I get no chats, and when I don't, I do get them, and I uh, like wasn't able to reply at that point. I was able to reply at the end, and it has been a like bit not good because I would like to reply during the live feed. But yeah, uh, probably when I have to monitor setup. JavaScript typed array are array-like objects that provide a mechanism for reading and writing new raw binary data in memory buffer. Okay, like objects that provide. Okay, array objects grow and shrink dynamically and can have JavaScript engine perform optimization so that these arrays are fast. However, as web applications become more and more powerful, adding features such as audio and video manipulation, access to raw data using WebSockets, and so forth, has become clear that there are times when it would be helpful for JavaScript code to be able to quickly and easily manipulate raw binary data. This is where a typed array come in. Each entry in the JavaScript typed array is a raw binary value. Am I in frame? Yep. In one or of the number of supported formats from 8-bit integers and 64 bits a floating point. 8-bit means 1 byte and 64 is like divided by 8 bytes. Yeah, it's it. I was double guessing myself. Um, Typed array objects share many of the same methods as array with similar semantics. However, typed arrays are not to be confused with normal arrays, as calling array.isArray on typed array returns false. Okay, so it's not like a normal array. It's like it does not. Basically, I don't think it will have the array prototype. So that would be the reason. Moreover, not all methods available for normal array are supported by typed arrays. Buffers and views. Typed array architecture. To achieve maximum flexibility and efficiency, JavaScript typed arrays implement into buffers and views. A buffer implemented array buffer object in an object repeating chunks of data. It has no format to speak of, they offer no mechanism for accessing its content. In order to access memory contained in the buffer, you need to use a view. A view provides a context that is data type, starting offset, and number of elements that turn the data into actual typed array. I guess Golang also uses this format for slices and arrays. I'm not very sure, but it seems like it because it's very similar. I haven't looked at the underlying mechanism of that, but yeah, it's very similar. If anybody knows, like write that in the comment if it's correct. Let's go lang slice implementation. Provides to It's similar. It seems like a similar thing. On like top level looking, it seems like a similar thing. If I'm wrong, please correct me. Um, the array buffer is a data type that is used to represent generic fixed length binary data buffer. You can directly manipulate the contents of array buffer instead of you create a typed array view or a data view which represents the buffer in specific format and use that to read and write the content of the buffer. Typed array views has self-descriptive name provided used to all the numeric int 8 and unit 8. There is one special typed array view, unit 8 clamped array, which clamps the value between 0 and 255. This is useful for canvas data processing. For example, all the types of arrays and their range. Data view. Data view is low level interface that provides a getter and setter API to write arbitrary data to the buffer. When this is useful when dealing with different types of data. For example, typed array view are in native byte order. See NDNS on the platform. With a data view, you are able to control byte order. Uh, it is being NDNS. How come organized bytes? Okay, so basically NDNS is this Excali. Let's say we want to represent. Uh, let's say. Oh, I lost this panel. But yeah, okay. Let's say we want to represent. Um, let's say 100. Okay, so if we have two ways to represent that 100, and the second way is 001. So one of them is big endianness and one of them is low end, like yeah, small, I guess. Uh, big endian, little and big. Okay, so light little endianness starts from is 001 and big endianness is 110. All web APIs using typed arrays. File render.product read array as buffer. The methods are reading the file contents, blob of file, the product.send. Okay, this is how we create an array buffer. First, we create a buffer has a fixed length of 16 bytes. So we provide the number of bytes, basically checking its size. So the byte length, and now we create an array of that. So we create a buffer. Now we create an array of and for a field of the array like normal array. Okay, so fill out four entries in the array, four entries, and add 4 byte each. Make six total bytes. Zero. Okay, cool. Okay. It's in 32. So 16 bytes. 16 into 8. 16 is into 8 is equals to 32 into 4. Therefore, four values can be stored. I guess that's what they are saying. Like, yeah, actually, that's what they're saying. We create a buffer. The buffer is of size 16 bytes. So it's actually 16 into 8 bits. So 128 bits. And 128 bits. Now we are creating an array of in 32. So each well, like item in the array will be of 32 bits. So divided by 32. So it's we can store four values, and uh, b- basically we are uh, getting the storage, and then we are creating an array, dividing it basically by using the multiple views on the same data in 16 buffer. Yeah, we can create this multiple views on the same data, and I guess we'll get eight. Things start to get really interesting when you consider that has created the 16 will share the same buffer. Yeah. Okay. So we can create like two arrays on the same buffer, and we can get different data. They are not telling us how that's stored, but mm, uh, 0246. By combining a single buffer with multiple views and different types, starting at different offsets into the buffer, you can interact with data objects containing multiple data types. This lets, for example, interact with complex data structures from WebGL or data files. Consider this C structure. Okay, struct, some struct, unsigned, and long as all. And you can choose the buffer containing data format like the buffer. You add a buffer of size 24 bytes. ID view is equals to unit 32 array buffer 01 username view buffer 416 amount view. Okay, from 0 to 1 byte. Hmm, seems like it. Oh, it starts with 0 and it goes till 1 byte, like 1 byte, and then it starts from 4, add on 16, so it ends on 20, starts from 20, and go. It needs 1 byte. I guess that's what they want. Or the okay. Size of float. So basically, one float. This is 16 arrays, 16 chars, and this is one long. So okay, so it's 16 into size of char, basically. 16 into size of basically unit, and 16 into size of float. Uh, Conversion to normal arrays. New unit array from we can use array.from to convert. Also the spread syntax. Also the spl- slice and call. Cool. Easy. It's easy. I understand. Like, basically, it's very simple. Well, when you want to more greater control on the memory, and basically in cases where you know how much data you have to store, you can take benefit of this where you declare how much memory you want, and then you can create views on that, and from the views you can get the data, and um, it can be very helpful for optimization purpose. Tomorrow we'll start memory management. We'll do memory management tomorrow. This is an easy topic, nothing too complex, and easy topics are always good. Uh, because like not a lot of brain, just understand it properly, and implement stuff on that later on, like not right now, but yeah. So, and it takes less time also. Simple, sober, easy usage. We'll do memory management tomorrow. Does JavaScript also? No, it's not like C. It so yeah. I guess we'll talk about garbage collection tomorrow, and that's good. Okay, thank you for joining. Um, I'll see you tomorrow. Bye bye.